I want to introduce a new concept called a unit vector. A unit vector is an arrow that is drawn to define which way is positive x, and if necessary you include one to define which way is positive y and which way is positive z. These unit vectors are pronounced x hat, y hat, and z hat. Often you will see I hat, j hat, and k hat instead. They mean the exact same thing. That's just a preference that mathematicians have when they're using unit vectors. But why would anyone want unit vectors? It's an especially useful way to describe a two-dimensional vector by listing its components instead of combining them with Pythagorean theorem and finding theta. Or for a three-dimensional vector also, which we're just not focusing on. So here's how unit vectors are used. In a previous video, I said that a two-dimensional vector, there's two common methods for denoting the location of a point, for example, a displacement vector, with respect to the origin. And I said it's analogous to explaining the location of a point in an xy Cartesian graph. So this red vector here represents a displacement that is 25 meters to the right and 8 meters upward. To describe this displacement, we would either say the displacement is 26.2 meters at an angle of 17.7 degrees above the x-axis, above the positive x-axis, or we could say the displacement is 25 meters x hat and plus 8 meters y hat. These mean the exact same thing. So if they mean the same thing, using unit vectors can spare us some algebra and some trigonometry, depending on the wording of the question. So, for example, in this slide, we have this vector in two dimensions. There's two ways to define the location of the point P, I said, relative to the origin. You could do an ordered pair x comma y, which is what we call Cartesian coordinates, or you could say the straight line from the origin to point P is some certain length and it is at some certain angle, and that's called polar coordinates. And to use these in physics, for any of these to have any physical meaning, they would be measurements, so we would include appropriate units every time. So just to clarify, if you know a vector in Cartesian coordinates and you need to put it in polar coordinates, you use the Pythagorean theorem to find the length of the single vector, and you find the angle using trigonometry, inverse sine or inverse cosine or inverse tangent. If you don't need to put it in polar coordinates, then you might choose to do so anyway. Example problems in the next video will help you sort of clarify when you need to do it and when you don't, and whether or not you would prefer to. Let me do one quick example here though, calling back to the slide that opened our previous video. In this problem, we are asked to find the displacement, we're given the displacement vector that is 123 kilometers at an angle of 45 degrees. So we're given it in polar coordinates. And we are asked to find the north and east components of this vector. So I want to find the components in a y direction, so I draw the dotted line on there in the y, like I had in the previous example. And I'm going to also include one in the x direction, the east direction. To find the displacement in the y direction, in the north direction, I'm going to point out that I have been given this 123 kilometers, which I've made into a hypotenuse for this triangle, and I was given this angle, which is 45 degrees. So if I'm looking for delta y, that's the side opposite my angle. Sine theta would equal opposite over hypotenuse, and it would allow me to relate the length of the hypotenuse to the length I'm looking for. So sine theta will equal delta y over the 123 kilometers we were given. I can rearrange this and say delta y is therefore sine of 45 degrees times 123 kilometers. Make sure that you are in degrees, not radians, in your calculator. Go ahead and put that in, and you should get that delta y is 87 kilometers. So Sacramento is 87 kilometers farther north than San Francisco, according to this math. And then to find delta x, I do something very similar, but I want the distance in the x direction. That's the side adjacent to the 45 degrees that I was given, so I'm going to use cosine instead. So the delta x is 87 kilometers also. That's just a trick of it being exactly 45 degrees in this case, but this process would have worked with any angle. So how do I give that answer? The answer to the question could be given as 87 kilometers x hat plus 87 kilometers y hat. Or I've never seen anyone use east and north as unit vectors, but you might say 87 kilometers east hat plus 87 kilometers north hat. It's just a slightly more awkward way of saying 87 kilometers east and 87 kilometers north. That slightly more awkward way of saying it is something that we actually are going to want to do mostly when we're writing it out, to make sure that we're being clear whether we've written something that is a vector notation or is not. I should point out the little hats that I've drawn on here are typed in. They should go directly over the x and the y and the east and the north. I just don't have a way to make the keyboard do that, but you'll see that in some of the examples that we have coming up. That's unit vectors.